To find the domain of a function, we must recognize what kind of function that is. And we're going to look at 3 different function types here. And we want to give all of our answers in interval notation. Note that. The first type we have are polynomials, which are sums, differences, that also have some exponents in them. And if you have a polynomial, the domain is all real numbers. Now, both of these functions, we have f of x equals 2x cubed minus 4x squared plus 5x minus 3, and f of x equals negative x squared plus 5. You should recognize that both of those are polynomials as we've been dealing with. So we will write the domain is all real numbers, which is the interval from minus infinity to positive infinity. So both of these will have the same domain, minus infinity to positive infinity. The second function type we see is an even root. And an even root has a domain that's equal to values so that the expression under the radical is positive or greater than or equal to 0. So our first function is f of x equals the square root of x plus 2. And this is an even root because it is a square root. Now we will take the radical, x plus 2. And we want to set x plus 2 greater than or equal to 0. Now we can isolate the x by subtracting 2 from both sides so that we have x is greater than or equal to negative 2. That is the range of x values that are valid. So we are going to say our domain, because this is greater than or equal to, let's stick this over here, greater than or equal to, closed dot, going to the right. So our interval is going to be bracket minus 2, comma, positive infinity, because we are greater than or equal to negative 2. The second we have function is f of x equals the square root of 5 minus x. We will again take our radical, specifically the radicand of that, 5 minus x, and we will set that greater than or equal to 0. So 5 minus x is greater than or equal to 0. We can subtract 5 from both sides so that we have minus x is greater than or equal to minus 5. And then dividing by negative 1 on both sides, we see that x is less than or equal to positive 5. And notice that whenever we divide or multiply by a negative number, the sign switches. So x is less than or equal to 5. Again, that is where our function is valid. That is its domain. So the domain for this, let me go ahead and draw a number line. We've got 5, and we are less than or equal to that. That goes to the left of positive 5. Which would make our domain minus infinity, parenthesis of course, to positive 5 with a bracket because we are including that. Now the last function type we're going to look at is a rational expression, which has a domain equal to all real numbers except where the denominator equals 0. That is still valid from our previous sections. So if we want to determine the domain of these functions, and the first function is f of x equals, the numerator is x minus 5, and the denominator is x squared plus 7x plus 10. That part's missing. What we need to do is work with the denominator. Set the denominator equal to 0. X squared plus 7x plus 10 equals 0. And we know from factoring and our quadratic section, this factors as x plus 2 times x plus 5 equals 0. And we can set each of these equal to 0. This results in subtracting 2 from both sides in the first equation, x equals minus 2. And in the second, we'll subtract 5 so that we have x equals minus 5. I'm going to add this in. We really are saying that x cannot be these things because we don't want the denominator to be 0. So I'm going to draw a number line over to the side. And I'm going to put a point. See here, negative 5 is on the left and minus 2 is on the right. I'm going to shade every part of this number line except for those two numbers. So from minus infinity up to -5, skip over -5, continue shading between -5 and -2, skip -2, and from -2 to positive infinity. And that is how I'm going to write my interval. Open parentheses, minus infinity, comma, -5. X cannot be that, so I will have a parenthesis, union, open parenthesis, -5, comma, -2, because I want between those two. Union, and I want to pick up after that, so -2, comma, infinity. Notice that I have parentheses everywhere because I am not including -5, and I'm also not including -2. But that covers the entire number line except for those two. Now our second function, we have f of x equals x is the numerator, divided by x minus 2 is the denominator. We'll follow the same procedure. We'll take x minus 2 equals 0, adding 2 to both sides. We see that x equals 2, which means, since that was our denominator, x cannot be equal to 2. So our domain will be minus infinity, comma 2, open or close parentheses, we want to not include positive 2, union 2, comma infinity, close parentheses.